Welcome to my projectbazaar.com. Now we discuss about the product Illumination Invariant Mean Shift Tracking. Now we discuss the abstract for the process. Visual tracking is a critical task in surveillance and activity analysis. One of the major issues in visual target tracking is variation in illumination. In this paper, we propose a novel algorithm based on discrete cosine transform, that is DCT, to handle illumination variation, since illumination variation are mainly reflected in the low frequency band. For instance, low illumination in the frame leads to low value DC coefficients as various and vice versa. We modify DC coefficient to achieve illumination variance. Average of DC coefficients of particular number of neighbor frames of current frame is taken. The correction in DC coefficient is performed using maximum eigenvalue of the image covariance matrix over n frames. The videos with corrected illumination are then used to track object of interest using the mean shift algorithm. The proposed algorithm is tested on the database. The result shows the quality of the tracking and significantly improved the accuracy of the process. Now we discuss the flow diagram for the process. At first, the input video is taken from the dataset. The dataset consists of the several videos as an dataset videos. After getting the input video from the dataset, the frame conversion is undertaken. The frame conversion is nothing but the video is converted into the sequence of images. The sequence of images is known as the frames. After extracting the number of frames from the single video, the frames are undertaken for the conversion of RGB to YUV. The RGB to YUV is the two formation. Basically the image, that is the frames, are in the form of RGB. The color transformation of the RGB to YUV is undertaken in this process. After the conversion of RGB to YUV, we have undertaken the frames into the process of illumination and DCT. The illumination is nothing but the illumination variance of the frames in between the frames in the video. If the illumination of the video frames is high, means the frame will be the brighter. If the illumination of the frame is low, means the frame will be the darker. So the illumination and DCT is nothing but the discrete cosine transform. The discrete cosine transform also applied for these all frames. After the applying illumination and the DCT for all frames, the background subtraction is undertaken. The background subtraction is nothing but the extracting the required object from that is the region of interest from the frames. By the background subtraction only, we have to extract the required object. After the background subtraction, the required object will be gathered. Then the object tracking is undertaken. The tracking is nothing but the tracking the required object using the bounding box segmentation. The bounding box is nothing but the box overlay on the required object. After the tracking, the analysis is carried out. The analysis is the performance analysis for the whole process. If the result of the performance analysis will be high, means the accuracy of the process and the performance of the process will be more efficient. Now we discuss the initial running procedure for the process. At first, select the main.m file and right click in that file. Then select the third option, that is run. Now the dialog box opened. In that you can see the several folders. In that, select the data folder and you can see the video file in the name of play. Select the video from that folder. After selecting the video was shown in the figure 1, and also the YUV frames are converted in also in the shown in the frame 3. Then the illuminated frame are shown in the figure 4. There are different type of illumination levels are shown in the figure 4, and in the figure 6 the YUV frame only shown. Then in this figure 7 the background subtraction is undertaken. In the background subtraction, only the background will be eliminated and the object remains the same. This is the binary frame. The binary frame consists of only the two values, that is the zeros and ones. The back area, that is an black area, is represented as an 0 and these white regions are represented as an ones. Then the object is tracking. This is the graph for the performance. Now we discuss the process one by one. This is the frames which is illuminated. There are 4 type of illumination in these frames. This is the background subtraction. I already discussed with this. This is the frame which is for the after the YUV conversion. Then this is the figure which represent the cropped region of interest. Then in the figure 10 you can see the tracked object even if the illumination of the frame is the very low. In that you can see the frames are very dark but the object is tracking. And then in the figure 11 you can see the performance of the process. The x-axis represent the frame and the y-axis represent the DCT value with the title DCT illumination variance with background frame. Then in the figure 2 also you can see the frames and DCT value of the coordinates, and the performance are shown in the figure 12. Thank you.